years away, is the second strongest radio source in the sky, second only to the sun. And we want to get important information like this out to folks, so we've featured some astronomical stuff on some of our products. Again, you can link to all of that at smAshomash.com. So let's do a cosmology segment, as there are some interesting stories to cover once again. And we like interesting stories, so let's cover them. All right, so the most distant radio galaxy ever seen has recently been discovered. It's located at 13 billion light years, and this is an artist's rendition that you're seeing here. It's Quasar P172 plus 18, and this gives me a great opportunity to show you that you are located someplace in this jet. Otherwise, it wouldn't be a quasar. And really, if you are located about here, that's a quasar, and if you're located just a little farther over there, it's a blazar. It all just has to do with how bright it is and your orientation. If you were oriented, say, here, it would look like a Seyfert 2 galaxy. If you're oriented here, maybe a Seyfert 1 galaxy. Now, this is odd, as we usually see radio emissions from these quasars when we're located at a perpendicular angle to the poloidal jets, which are shown here in blue. Those are the polar field jets, the poloidal jets from that radio galaxy. And in any case, P172 plus 18 must be a pretty organized galaxy, or it wouldn't have jets like that, right? So how is it 13 billion years old? Does this fly in the face of the age of the universe and the Big Bang? Well, indeed it does. And you can find this article on SciTech Daily. It's probably on other science wires as well. And the estimated mass of the core of the massive radio source located at the core of that galaxy is estimated to be 300 million times the mass of the sun. And we try to call things massive radio sources, something that I noticed in the mid-1990s. Some folks were calling massive radio sources black holes, and other folks continue to call them massive radio sources. I won't get more in-depth into that in today's cosmology segment. Perhaps you'd like to check out the article on SciTech Daily. It's right on their homepage today. And let's pick a random number between 1 and 1031. How about 620? Why? It coincides with an object at the Neil Gehrels Swift Observatory, the Burst Alert Telescope. So what's 620, you ask? 620 is RxJ 1709.5-2639, a low-mass X-ray binary. So most likely a star in the Milky Way galaxy. And look, this is very interesting here. So this particular star, this low-mass X-ray binary, had a period when it stopped emitting X-rays for like over a year, nearly 2 years. RX 1709.5-2639 shut down in terms of X-rays. Now, apparently this is a thing that it does regularly, because look right here on the daily graph, you can see it shut down there again. So this is an interesting variable star here, to say the least. And here's a 30-day chart. You can see it maybe has some 30-day cyclicity going on there. In any case, maybe we'll have to look more in depth into this one. RxJ 1709.5-2639, a catchy name. Let's take a look at it on Aladdin Light. And not a lot to see there invisible. How about an infrared, which often shows us more? It's the 2 mass. And we don't really see jack on the 2 mass either. Let's check its X-ray outputs. How about the multi-mirror project? Nope. And not really on Chandra either. Let's look at it in blue light, as sometimes blue light gives us additional information, and not really. It's pretty dark in most wavelengths, folks. So that's today's random, quote, random cosmic object in today's cosmology segment. And thanks for leaving comments John Kotowski, one of our patrons, aka Life Force Rejuvenation. Perhaps check out his YouTube page as well. And we've got one more story here. I just want to briefly talk about the Primer fields. So you may have heard of the Primer fields. It's David LaPointe's work using specially made magnetic cups. And here he's gonna blast dark energy.
Will also eject matter at high velocities.
And the Primer fields is one of the theories as to how things like galactic jets form. So perhaps watch the Primer fields part 1. And by the way, if you're one of those folks out there who believes that stars are electric, and you're sending me links to David LaPointe's work or perhaps Pierre-Marie Robitaille's work, you may want to know that neither of those guys think stars are electric either. David LaPointe and Pierre-Marie Robitaille do not believe stars are electric, and neither do I. We're more interested in their fundamental nature, and we would probably see all kinds of evidence if stars were electric. And one of the reasons why we study the sun so in depth is because I consider the sun to be cosmology. So, heliophysics. Until we understand the way the sun behaves, folks, we're not going to understand cosmology, as all cosmology is based on the evolution of the sun. So the similarities between the sun and other stars and so on has to do with the way all of cosmology is, quote, understood, end quote. So here's an article on universetoday.com talking about very detailed analysis, magnetic analysis of the chromosphere. So we've got two different orbiters right now, the Parker Solar Probe, which is the fastest object ever built by mankind, and the ESA's solar orbiter. And they're both collecting lots of data right now. And what's going on inside the sun is kind of important in that the sun is the Rosetta Stone of cosmology, folks. And until we have a reasonable explanation of the sun's behavior, the idea that we know what's going on in the cores of distant galaxies is just insane. And it's not to say that the work of all modern astronomy is just pointless. That's not true at all. The data that they're gathering is more than relevant and more than useful. It's just that until we understand heliophysics, the idea that we understand what's going on Deneb, or what's going on at Sagittarius A star, or what's going on at the core of the galaxy 3C405, otherwise known as Cygnus A, the second most massive radio source in the sky, is just silly and insane. So, more about this later. Maybe check out this article on Universe Today about space missions building up a detailed map of the sun's magnetic field. And that's today's Cosmology.